Prisma Access. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. In this comprehensive presentation, we will explore Palo Alto Networks' Prisma Access, a cloud-delivered secure access service edge solution that is transforming how organizations approach network security. The modern enterprise faces a significant challenge: securing users who are no longer confined to traditional office perimeters while simultaneously protecting access to applications that now reside across data centers, public clouds, and software-as-a-service platforms. Prisma Access addresses this challenge by delivering consistent security to all users regardless of their physical location. Whether your employees are working from corporate headquarters, connecting from branch offices, or accessing resources while traveling on the road, Prisma Access ensures they receive the same level of protection through a unified cloud-based security infrastructure. The fundamental premise of Prisma Access is to safely enable users to access cloud and data center applications as well as the internet without compromising security. By consistently inspecting all traffic across all ports, Prisma Access provides secure access to the internet, sanctioned software-as-a-service applications, public cloud environments, and corporate data centers and headquarters locations. Prisma Access Architecture Overview. Let me walk you through the high-level architecture of Prisma Access. The architecture consists of multiple interconnected components that work together to deliver comprehensive security. The diagram illustrates the core components of Prisma Access. Mobile users connect through GlobalProtect app or Explicit Proxy to the Mobile User Security Processing Nodes, abbreviated as MU-SPNs. These cloud-based firewall instances are dedicated to processing traffic from mobile endpoints. Branch offices and remote networks establish IPsec VPN tunnels to connect to remote network security processing nodes, known as RN-SPNs. These nodes secure traffic for entire site locations rather than individual users. The Service Connection Corporate Access Nodes, called SC-CANs, provide connectivity between Prisma Access and your corporate headquarters, data centers, and private applications. This enables mobile users and remote network users to access internal resources securely. All components connect through the Prisma Access Cloud Backbone, which provides the network fabric for communication. The security-as-a-service layer applies consistent security policies including threat prevention, URL filtering, and application control. Finally, all logs flow to the Strata logging service for centralized analysis and forensics. Prisma Access encrypts data end-to-end between all these components. Traffic is encrypted between MU-SPNs and RN-SPNs, between SPNs and SCCANs, and between SCCANs and the data center, ensuring comprehensive protection throughout the entire path. Mobile users with GlobalProtect. GlobalProtect is the primary method for connecting mobile users to Prisma Access. It provides consistent security for your mobile users whether they are accessing applications at your data center, using software-as-a-service applications, or browsing the internet. The diagram illustrates the mobile user connection flow. The mobile user runs the GlobalProtect application on their endpoint device. GlobalProtect is available for smartphones, tablets, and laptops running Microsoft Windows, Apple Mac OS and iOS, Android, Google Chrome OS, and Linux operating systems. The GlobalProtect app connects to the GlobalProtect portal, which is the initial point of contact. The portal authenticates the user and provides configuration information. After authentication, traffic flows through the VPN tunnel to the Mobile User Security Processing Node. The MU-SPN performs full traffic inspection using the next-gen firewall capabilities. This includes App ID for application identification, threat prevention, URL filtering, and secure sockets layer decryption. Based on the security policy evaluation, traffic is either allowed to proceed to its destination or blocked. A critical capability of GlobalProtect is host information profile reporting. The GlobalProtect app collects information about the device state, including whether it has the most up-to-date patches, encryption is enabled, and virus definitions are current. This HIP information allows you to create granular policies based on device state, ensuring that only compliant endpoints can access your most sensitive applications. Prisma Access dynamically scales in and out per region based on where your users are at the moment. This elasticity ensures optimal performance regardless of user distribution. Service Connections Deep Dive. Service connections provide the critical link between Prisma Access and your internal network resources. They enable mobile users and users at remote networks to access private applications hosted in your headquarters, data centers, or cloud environments. The diagram illustrates the service connection architecture. Your corporate HQ or data center hosts internal applications and resources. The HQ firewall or router establishes an IPsec tunnel to the service connection corporate access node within Prisma Access. Once this tunnel is established, internal applications become accessible. Mobile users access these applications through the MU-SPN, which routes traffic to the SCCAN. Remote network users similarly access internal applications with their traffic flowing through the RN-SPN to the SCCAN. Even if you don't have private applications that mobile users need to access, Palo Alto Networks recommends creating a service connection with placeholder values. This enables network communication between mobile users and remote network locations, and between mobile users in different geographical locations. Without a service connection, these user groups cannot communicate with each other through Prisma Access. The number of service connections available depends on your license. Local edition licenses provide up to 2 service connections, while worldwide edition licenses allow up to 5. The ZTNA Connector provides an alternative approach for private application access that we will discuss in a later slide. Security Services Stack. Prisma Access delivers a comprehensive security services stack that provides consistent protection regardless of where your users are located or what resources they are accessing. Let me walk through each layer of security capabilities. The diagram shows the layered security architecture. At the foundation, you have Firewall as a Service capabilities providing next-generation firewall functionality including application control, user-based policies, and network segmentation. The threat prevention layer protects against known vulnerabilities, exploits, and malware. This includes intrusion prevention system signatures and anti-malware capabilities that are continuously updated. URL filtering controls access to websites based on categories and reputation. You can allow or block access to different types of web content based on your organization's acceptable use policies. Secure Sockets Layer/TLS decryption is critical because the majority of web traffic today is encrypted using HTTPS. Without decryption, security services cannot inspect the actual content of connections. Prisma Access can decrypt this traffic for inspection and then re-encrypt it before forwarding. Domain Name System Security provides a combination of predictive analytics, machine learning, and automation to combat threats in domain name system traffic. Organizations can block known malicious domains, predict new malicious domains, and stop domain name system tunneling attacks. Advanced WildFire is the cloud-based sandboxing service that analyzes unknown files in a safe environment to identify zero-day malware. Suspicious files are submitted for analysis and verdicts are returned in near real time. Enterprise data loss prevention helps prevent sensitive data from leaving your organization through unauthorized channels. You can define policies to detect and block transmission of confidential information. Management options. Prisma Access offers 2 management approaches, and you must decide which one to use before getting started with your deployment. Each option has its own advantages depending on your existing infrastructure and requirements. The diagram illustrates the 2 management paths. The first option is Prisma Access managed by Strata Cloud Manager. This is cloud-native management through a web-based interface. Strata Cloud Manager provides task-driven workflows that allow you to set up and test your environment in minutes. Cloud management simplifies onboarding by providing predefined internet access and decryption policy rules based on Palo Alto Network's best practices. You can quickly set up IPsec tunnels using defaults suitable for the most common IPsec-capable devices and easily enable secure sockets layer decryption for recommended URL categories. The Strata Cloud Manager Command Center provides dashboards for assessing network health, visibility, and an overview of your data. The second option is Prisma Access managed by Panorama. This uses the Cloud Services plugin on Panorama to set up and manage Prisma Access. This is an excellent option if you are already using Panorama to manage next-generation firewalls and you have a common policy that you want to apply for access to your corporate applications. If you have an existing Panorama managed deployment and want to migrate to Strata Cloud Manager, Palo Alto Networks offers an in-product workflow to migrate your configuration. However, you cannot migrate from a Strata Cloud Manager deployment back to a Panorama managed deployment, so choose carefully. There are some feature differences between the two management options. The compatibility matrix in the Palo Alto Networks documentation provides detailed information about which features are supported in each management interface. ZTNA Connector Introduction. The Zero Trust Network Access Connector, commonly referred to as ZTNA Connector, represents a significant advancement in how organizations can provide secure access to private applications. It offers an alternative to traditional service connections that simplifies deployment while enhancing security. ZTNA Connector lets you connect Prisma Access to your organization's private applications simply and securely. It provides mobile users and users at branch locations access to your private apps using an automated secure tunnel. The key advantage is that you don't have to manually set up IPsec tunnels and routing definitions to access private apps in your data centers, headquarters locations, public cloud environments, or partner networks. The diagram illustrates the Zero Trust Network Access Connector architecture. The Zero Trust Network Access Connector virtual machine is deployed within your environment, whether that's in Amazon AWS, Google GCP, Microsoft Azure, VMware ESXi, or AKVM Hypervisor. Palo Alto Networks recommends deploying the virtual machine in the same subnet as the applications you want to onboard. Once deployed, the connector virtual machine automatically discovers the nearest Prisma Access location and initiates a secure IPsec tunnel. This automatic tunnel establishment eliminates the manual configuration typically required for service connections. The connector then connects your private applications to Prisma Access, making them accessible to mobile users and remote network users. Each Zero Trust Network Access Connector supports bandwidth up to 2 gigabits per second. For higher bandwidth requirements or redundancy, you can deploy multiple connectors within a connector group, supporting up to 4 connectors per group. ZTNA Connector Components. Let me explain the key components that make up a ZTNA connector deployment. Understanding these components will help you plan and implement your private application access strategy effectively. The diagram shows the 3 main components. First, we have connectors. Connectors are the virtual machines that build tunnels to Prisma Access. Zero Trust Network Access Connector automates tunnel management without you having to specify IPsec and IKE settings manually. You deploy connector virtual machines in your cloud service provider or virtual infrastructure, and after installation, they automatically discover the nearest Prisma Access location and initiate a secure tunnel. After deploying the connector virtual machine, Prisma Access manages the virtual machine, including providing options to upgrade the virtual machine version. This managed approach reduces operational overhead compared to traditional service connections. Second, we have connector groups. A connector group is a logical grouping of connectors and applications. By adding multiple connectors in a connector group, you provide tunnel redundancy and increased bandwidth to the applications within the group. Each connector group supports up to 4 connectors. If you want to provide access to specific applications using different connectors, You place the connectors in separate groups. Third, we have targets. Targets are the private applications that ZTNA Connector onboards to Prisma Access. You can define specific applications to which you want to provide access using FQDN targets, wildcard targets, or IP addresses and subnets where the applications are located. An important security benefit is that the private IP addresses of your applications are not exposed when using ZTNA Connector. Strata Logging Service Overview. Strata Logging Service is the cloud-native logging infrastructure that serves as the foundation for log management across the entire Palo Alto Network's Strata ecosystem. All Prisma Access logs are automatically forwarded to Strata Logging Service, providing centralized analysis, reporting, and forensics across all users, applications, and locations. The diagram shows the Strata Logging Service architecture. Multiple log sources feed into the service. Prisma Access generates logs for all traffic processed by mobile user SPNs, remote network SPNs, and service connection CANs. Next-generation firewalls including both hardware PA series and virtual VM series can also forward logs. Additionally, Prisma SD-WAN and cloud services like the Prisma Access browser contribute log data. Strata Logging Service provides the cloud log storage infrastructure. This is a scalable, secure, and resilient storage layer that eliminates the need for you to plan and deploy log collectors to meet your retention needs. The service automatically scales to handle large volumes of log data without requiring customer-managed infrastructure. The log analysis capabilities provide tools for querying, filtering, and investigating log data. You can search across all log types to correlate events and identify security incidents. Flexible retention options allow you to meet compliance requirements and support forensic analysis. Specific retention periods are typically determined by your license. Finally, log forwarding enables you to send logs to external systems. You can forward logs to your SYS log server, security information and event management system, or other analysis platforms. An important note is that log traffic does not use the licensed bandwidth you purchased for Prisma Access. This means your security logging doesn't compete with user traffic for bandwidth allocation. Prisma Access Insights APIs. The Prisma Access Insights APIs allow you to programmatically query your Prisma Access tenants for data resources. This enables automation, custom reporting, and integration with your existing tools and workflows. The diagram shows the API architecture. Your custom applications or scripts make API calls to query Prisma Access data. Two versions of the API are available, each using different authentication mechanisms. The 2.0 APIs are intended primarily for Prisma Access deployments managed by Strata Cloud Manager. These tenants have been onboarded using a Tenant Service Group 1D, commonly called TSGID. To determine if your tenant uses TSGIDs, go to the Prisma Access Hub, click on the Prisma Access Insights application name, and look in the Manage Apps section. The 2.0 APIs can also be used by Panorama managed deployments. In multi-tenant Panorama scenarios, only the supertenant has the TSGID, and subtenants are included in the header with the Strata Logging Service tenant ID. The 1.0 APIs are intended for all Strata Cloud Manager single-tenant customers, as well as Panorama-managed single-tenant and multi-tenant customers. The mechanism for obtaining access tokens differs between the two versions. API responses return data resources including health information, tunnel status, user activity, and other operational data. You can use this data to build custom dashboards, generate reports, or trigger automated responses to operational conditions. The API calls themselves are the same between versions. The primary difference is the authentication token format and how you obtain the token. Detailed documentation for both API versions is available on the Palo Alto Network's developer portal. Traffic flow for mobile users. Understanding how traffic flows through Prisma Access for mobile users is essential for troubleshooting and optimizing your deployment. Let me walk you through the complete traffic flow from a mobile user accessing the Internet. The sequence diagram shows the step-by-step flow. The mobile user initiates a connection, which prompts the GlobalProtect application to establish a VPN tunnel to the mobile user security processing node. The GlobalProtect app sends user authentication credentials and host information profile data to the MU-SPN. The MU-SPN validates the user authentication and evaluates the HEPA data against configured policies. If authentication succeeds and the device meets HEPA requirements, the tunnel is established. When the user requests access to an Internet resource, the traffic flows through the VPN tunnel to the MU-SPN. The security stack on the MU-SPN inspects the traffic, identifying the application using app ID, checking for threats, and evaluating URL categories. If the traffic passes all security policy checks, the MU-SPN forwards it to the Internet destination. The MU-SPN performs source NAT, translating the user's private IP address to the MU-SPN's external IP address. This ensures return traffic flows back through the same path. Response traffic from the Internet returns to the MU-SPN, which performs reverse NAT and additional security inspection before forwarding the response through the VPN tunnel to the user. Throughout this flow, the MU-SPN generates logs for each session and forwards them to Strata logging service for storage and analysis. The entire process happens transparently to the user, who simply experiences secure access to Internet resources. Traffic flow for private applications. When mobile users need to access private applications hosted in your data center or cloud environment, the traffic flow involves additional components. Let me explain how this works using service connections. The sequence diagram shows the complete flow. The mobile user's GlobalProtect app establishes a VPN tunnel to the MU-SPN, just as with Internet access. The user then requests access to a private application, and this request flows through the tunnel to the MU-SPN. The MU-SPN recognizes that the destination is a private application based on the configured routes and forwards the traffic to the Service Connection Corporate Access node. The SC-CAN maintains an IPsec tunnel to your headquarters firewall. The traffic traverses this IPsec tunnel to reach your corporate network. The HQ firewall routes the traffic to the private application server. The application processes the request and sends the response back through the same path. Security inspection occurs at multiple points in this flow. The MU-SPN inspects traffic from the mobile user. The SCCAN can apply additional policies. Your HQ firewall enforces your on-premises security policies. This layered approach ensures comprehensive protection. For organizations using Zero Trust Network Access Connector instead of service connections, the flow is similar, but the Zero Trust Network Access Connector virtual machine handles the connectivity to private applications. The connector automatically establishes and manages the tunnel, simplifying the configuration required on your side. All traffic in both directions is logged, providing complete visibility into private application access patterns and enabling security investigation when needed. Prisma Access Licensing Model. Understanding the Prisma Access licensing model is essential for planning your deployment and ensuring you have the appropriate capabilities for your organization's needs. Palo Alto Networks offers several license editions that provide different levels of functionality. The diagram shows the license hierarchy. At the foundation, you have the core Prisma Access license, which provides the base platform capabilities. On top of this, you choose an edition that determines your feature set and geographic reach. The ZTNA edition provides Zero Trust Network Access capabilities focused on securing access to private applications. This is suitable for organizations primarily concerned with secure remote access to internal resources. The Enterprise Edition builds on Zero Trust Network Access and adds comprehensive security services, including the full secure web gateway functionality, advanced threat prevention, and data loss prevention capabilities. This edition is designed for organizations that need complete security coverage for all user traffic. Within each edition, you choose between local and worldwide deployment options. Local edition restricts your deployment to a limited number of locations, typically suitable for organizations with a concentrated geographic presence. Worldwide edition removes these location restrictions, allowing you to deploy across all available Prisma Access points of presence globally. The number of service connections also varies by edition. Local editions provide up to 2 service connections, while worldwide editions allow up to 5. If you manage multiple tenants with an enterprise license, the number of service connections per tenant depends on the units you allocate. Additionally, Strata logging service requires its own license with appropriate storage allocation for your log retention requirements. Security Policy Architecture. Prisma Access security policies determine how traffic is handled as it flows through the platform. Understanding the policy architecture helps you implement effective security controls that protect your organization while enabling productivity. The diagram shows the policy evaluation flow. When traffic enters Prisma Access, it first undergoes application identification using App ID technology. This identifies the application regardless of port, protocol, or encryption. Unlike traditional firewalls that rely on port numbers, App ID provides accurate application visibility. Next, user identification associates the traffic with a specific user through user ID. This can come from the GlobalProtect authentication, directory integration, or other user mapping sources. User ID enables you to create policies based on users and groups rather than just IPs. Device identification through device ID and host information profiles adds another dimension. HIP data collected by GlobalProtect tells you about the device's security posture, including patch level, encryption status, and antivirus definitions. You can require devices to meet specific criteria before allowing access to sensitive resources. With the traffic fully identified, the security policy rules are evaluated. Rules are processed in order from top to bottom, and the first matching rule determines the action. Policies can allow, deny, or allow with additional inspection and logging. For allowed traffic, security profiles provide additional protection. These include antivirus, anti-spyware, vulnerability protection, URL filtering, file blocking, and data filtering profiles. Traffic matching and allow route can still be blocked if it triggers a security profile. Finally, the policy decision determines whether traffic is allowed to proceed to its destination or is blocked. All decisions are logged for visibility and compliance. Device groups and templates. When managing Prisma Access through Panorama, you work with device groups and templates to organize and deploy your configuration. Understanding this hierarchy is essential for effective policy management. The diagram shows the configuration hierarchy. At the highest level, the shared device group contains configuration that applies across your entire deployment. This is where you place common objects, profiles, and policies that should be consistent everywhere. Below shared, Prisma Access automatically creates specific device groups for different connection types. The Mobile User Device Group contains policies and objects specific to GlobalProtect mobile users. The Remote Network Device Group holds configuration for branch office remote networks. The Service Connection Device Group manages settings for service connections to your data centers. Templates work similarly for device-level configuration. The Mobile User Template contains GlobalProtect portal and gateway settings, certificate configurations, and other device settings for mobile users. The Remote Network Template holds IPsec tunnel parameters and routing configuration. The Service Con Template manages service connection tunnel settings. When you configure Prisma Access, you can add a parent device group that contains configuration settings you want to push to the service. You will push all configuration including address groups, security policies, security profiles, policy objects, HIP objects and profiles, and authentication policies using the device group hierarchy you specify. This hierarchical approach allows you to maintain common policies at the shared level while customizing settings for specific use cases in the child device groups. Changes made at higher levels automatically propagate down unless overridden. Domain Name System Security Integration. Domain name system security is a critical layer of protection that addresses threats at the domain name resolution level. Because virtually all network communication begins with a domain name system query, controlling and inspecting domain name system traffic provides an effective early detection and prevention point. The diagram shows the DNS security architecture. When a user device makes a DNS query to resolve a domain name, that query flows through Prisma Access. Before returning a response, the DNS security service evaluates the requested domain. The known malicious domains database contains signatures for domains that have been confirmed as malicious through threat intelligence. Queries for these domains are immediately blocked, preventing the connection before it even begins. Predictive analytics uses machine learning to identify new malicious domains that haven't yet been added to block lists. By analyzing domain characteristics, registration patterns, and other signals, the system can predict with high accuracy whether a newly observed domain is likely malicious. Domain name system tunneling detection identifies attempts to exfiltrate data or establish command and control channels by encoding information within domain name system queries. This technique is commonly used by advanced threats to bypass traditional security controls. When a domain is determined to be safe, the DNS response returns the resolved IP address and the connection proceeds normally. When a domain is malicious or suspicious, the query is blocked and the user sees a blocked page or connection failure. Domain name system security provides protection even for traffic that isn't inspected through other security services. This makes it an effective catch-all layer that complements your other security controls. High availability and redundancy. Prisma Access is designed for high availability with multiple layers of redundancy built into the architecture. Understanding these redundancy mechanisms helps you design deployments that meet your availability requirements. The diagram illustrates the redundancy architecture. At the infrastructure level, multi-cloud architecture provides resilience by deploying across multiple cloud providers. This protects against provider-specific outages and ensures global coverage. Hot standby SPN pairs are deployed in multiple availability zones. If a primary security processing node fails, the standby takes over immediately. This architecture delivers the industry-leading 99.999% uptime SLA with less than 26 seconds of downtime per month. For mobile users, GlobalProtect supports multiple gateway connections. If one gateway becomes unavailable, the client automatically fails over to an alternate gateway. The gateway selection can be based on geographic proximity, load, or manual priority settings. Remote networks can be configured with redundant IPsec tunnels to different Prisma Access locations. Active/active or active/standby configurations provide continuous connectivity even if one tunnel fails. ECMP routing enables load balancing across multiple links for both performance and redundancy. Service connections similarly support redundant tunnel configurations. You can establish tunnels from your headquarters to multiple Prisma Access locations, ensuring that private application access remains available even during regional issues. The global network backbone leverages the robust networks of hyperscale cloud providers, including their own fiber optic infrastructure and direct peering agreements with major software as a service and infrastructure as a service providers. This ensures fast, reliable connectivity that bypasses public internet congestion. Troubleshooting connectivity issues. Even well-designed deployments occasionally experience connectivity issues. Understanding common problems and troubleshooting approaches helps you quickly resolve issues and minimize impact to users. The diagram shows a troubleshooting decision tree. When users report connectivity issues, start by determining the scope. Is the issue affecting a single user, multiple users at one location, or all users globally? The scope often points to the root cause. For single-user issues, check the GlobalProtect client first. Verify the client is connected and authenticated. Review the client logs for error messages. Check if the user's device meets HIPAA requirements, as non-compliant devices may be blocked by policy. Verify network connectivity from the user's location to the GlobalProtect portal. For issues affecting multiple users at one location, investigate the remote network connection. Check the IPsec tunnel status in the Prisma Access console. Verify that the on-premises router or SD-WAN device is functioning correctly. Review BGP peer status if using dynamic routing. Check for any network issues between the branch and the Prisma Access point of presence. For widespread issues affecting all users, check the Prisma Access service status page for any reported incidents. Review recent configuration changes that might have impacted connectivity. Check Strata logging service for patterns in blocked traffic that might indicate a policy misconfiguration. The Prisma Access console provides diagnostic tools including tunnel status, user connection details, and traffic logs. For Zero Trust Network Access connector issues, use the built-in ping, traceroute, and NS lookup diagnostic tools to verify application reachability from the connector. When escalating to Palo Alto network support, gather relevant logs, configuration details, and a clear description of the symptoms and timeline. This information helps support engineers diagnose issues more quickly. Multi-tenancy architecture. Prisma Access multi-tenancy enables organizations to manage multiple separate Prisma Access instances from a single management plane. This is particularly valuable for managed service providers, large enterprises with distinct business units, or organizations that need to maintain strict separation between different environments. The diagram illustrates the multi-tenant architecture. At the top level, the management plane provides centralized administration capabilities. From here, administrators can manage multiple tenants while maintaining appropriate access controls and separation. Each tenant represents an independent Prisma Access instance with its own configuration, policies, users, and resources. Tenant A, Tenant B, and Tenant C. In the diagram, each have their own mobile users, remote networks, and service connections that are completely isolated from other tenants. The shared infrastructure layer provides the underlying platform capabilities that all tenants use, but tenant data and traffic remain strictly separated. Each tenant gets dedicated security processing nodes with dedicated compute and network resources, ensuring consistent performance without noisy neighbor effects. Prisma Access supports up to 200 tenants on a single multi-tenant deployment. The number of service connections per tenant depends on the units you allocate and the type of license you have. If you have a global license and allocate at least 1,000 units for a tenant, you can allocate a maximum of 5 service connections for that tenant. For Panorama-managed multi-tenant deployments, the supertenant holds the TSG ID, and subtenants are identified using the Strata logging service tenant ID. This hierarchy is important when using the Prisma Access APIs to query specific tenant data. Migration from Panorama to Strata Cloud Manager. If you have an existing Prisma Access deployment managed by Panorama and want to take advantage of the streamlined workflows in Strata Cloud Manager, Palo Alto Networks provides an in-product migration workflow. Understanding this process helps you plan a smooth transition. The diagram shows the migration workflow. You begin with your existing Panorama deployment, which contains all your current Prisma Access configuration including policies, objects, templates, and device groups. The migration assessment phase involves reviewing your current configuration to identify any features or settings that may need adjustment for Strata Cloud Manager. The compatibility matrix documents differences between the two management platforms. During configuration export, the migration workflow extracts your Prisma Access configuration from Panorama. This includes security policies, network configurations, authentication settings, and other relevant parameters. The configuration import process loads your exported configuration into Strata Cloud Manager. The migration tool handles the translation of Panorama-specific constructs to their Strata Cloud Manager equivalents. After import, you perform validation and testing to ensure the migrated configuration works correctly. This should include testing all connection types, mobile users, remote networks, and service connections. Finally, the cutover to Strata Cloud Manager makes the cloud management platform the authoritative source for your Prisma Access configuration. After cutover, you manage Prisma Access exclusively through Strata Cloud Manager. An important consideration is that this migration is one-way. You cannot migrate from a Strata Cloud Manager deployment back to a Panorama managed deployment, so ensure you are ready for this transition before proceeding. Monitoring and reporting. Effective monitoring and reporting are essential for maintaining visibility into your Prisma Access deployment, identifying security incidents, and demonstrating compliance. Prisma Access provides comprehensive capabilities through multiple interfaces. The diagram shows the monitoring and reporting architecture. Data collection happens continuously as Prisma Access processes traffic. Every session generates log entries that capture detailed information about the connection, security decisions, and any threats detected. The Strata logging service stores all this log data in a scalable cloud infrastructure. From here, the data feeds into multiple analysis and reporting capabilities. Real-time dashboards in Strata Cloud Manager Command Center provide immediate visibility into current activity. You can see active users, traffic volumes, threat detections, and system health at a glance. These dashboards update continuously to reflect the current state of your deployment. The Insights capability analyzes patterns in your data to surface important findings. AIOps features can identify anomalies, performance issues, and optimization opportunities that might not be obvious from looking at raw data. Alerts and notifications can be configured to notify administrators when specific conditions occur. You can set thresholds for traffic volumes, threat detections, or system health metrics that trigger alerts through email, webhook, or integration with your incident management system. Scheduled reports can be generated automatically and distributed to stakeholders. These reports can summarize security posture, compliance status, usage patterns, and other metrics over defined time periods. For organizations that need to retain logs longer than Strata logging service provides, or that want to correlate Prisma Access logs with other data sources, log forwarding sends logs to external SIM systems or syslog servers. Data loss prevention capabilities. Enterprise data loss prevention in Prisma Access helps prevent sensitive data from leaving your organization through unauthorized channels. DLP provides consistent control across all traffic inspected by Prisma Access, including web traffic, software as a service applications, and private application access. The diagram shows the DLP architecture. Traffic flowing through Prisma Access passes through the DLP inspection engine. This engine examines content for sensitive data patterns using multiple detection methods. Data patterns define what constitutes sensitive information. Prisma Access includes predefined patterns for common data types like credit card numbers, social security numbers, and other personally identifiable information. You can also create custom patterns using regex or keyword lists to detect organization-specific sensitive data. The data loss prevention profiles configure how detected sensitive data should be handled. For each data pattern, you can specify whether to alert, block, or allow the traffic. You can also configure different actions based on the volume of sensitive data detected or the destination of the traffic. Policy integration ties data loss prevention into your overall security policy. Data loss prevention profiles are attached to security rules, allowing you to apply different data loss prevention controls based on user, application, or destination. For example, you might allow certain users to send files containing financial data to approved partners while blocking the same data from being uploaded to personal cloud storage. When data loss prevention detects a policy violation, it can generate alerts and incidents that are visible in the monitoring dashboards, These notifications help security teams identify potential data exfiltration attempts or policy violations that need investigation. An important benefit is that data loss prevention policies work consistently across private applications and software as a service applications with a single policy definition. This unified approach simplifies administration and ensures consistent protection regardless of where users are sending data. Prisma Access Use Cases Summary. Throughout this presentation, we have covered the technical capabilities of Prisma Access. Let me now summarize the key use cases where organizations deploy Prisma Access to solve real business challenges. The diagram organizes the primary use cases. Secure remote workforce is often the initial driver for Prisma Access adoption. With more employees working from home or on the road, organizations need to provide secure access to corporate resources without the complexity and performance limitations of traditional VPN infrastructure. Prisma Access delivers this through GlobalProtect with cloud-scale capacity. Branch office security addresses the challenge of securing distributed locations without deploying hardware firewalls everywhere. Remote networks provide cloud-delivered next-generation firewall protection for branch offices, with simplified management and automatic updates. Cloud and software as a service security ensures that access to cloud applications is protected regardless of where users connect from. The secure web gateway capabilities inspect all web traffic, while CASB features provide visibility and control over software as a service application usage. Zero Trust implementation is enabled by the combination of identity-based access control, continuous verification, and comprehensive inspection that Prisma Access provides. ZTNA Connector simplifies secure access to private applications following Zero Trust principles. Network transformation supports organizations moving away from traditional hub-and-spoke network architectures. By providing security in the cloud, Prisma Access enables direct internet access from any location while maintaining consistent security controls. Compliance and governance requirements are addressed through comprehensive logging, reporting, and policy enforcement capabilities. Organizations can demonstrate that security controls are consistently applied across all users and locations. Summary and next steps. We have covered a comprehensive overview of Palo Alto Network's Prisma Access throughout this presentation. Let me summarize the key takeaways and suggest next steps for your journey with Prisma Access. Prisma Access delivers cloud-native security that scales globally. The architecture of security processing nodes, service connections, and the Prisma Access backbone provides consistent protection for all users regardless of location. The platform eliminates the need to deploy and manage hardware security appliances at every location. Multiple connectivity options address different requirements. GlobalProtect secures mobile users with always-on or on-demand VPN connectivity. Remote networks protect branch offices through IPsec tunnels. ZTNA Connector simplifies private application access. Explicit Proxy supports organizations with existing proxy architectures. Comprehensive security services are built into the platform. Firewall as a service, threat prevention, URL filtering, secure sockets layer decryption, DNS security, WildFire sandboxing, and data loss prevention work together to provide defense in depth. All traffic is inspected consistently, closing the visibility gaps that exist with point solutions. Flexible management options let you choose the approach that fits your organization. Strata Cloud Manager provides streamlined cloud-native management with best practice policies. Panorama integration leverages your existing investment and enables unified management of on-premises and cloud security. For next steps, I recommend reviewing the Prisma Access documentation for your specific deployment scenario. Consider starting with a proof of concept to validate the platform in your environment. Engage with your Palo Alto Networks account team or partner to discuss licensing options and deployment planning. Thank you for your attendance. Please consider subscribing to the channel and liking this video.